This is a video presentation of Chapter 7, Section 6, which is entitled Line Graphs. In this section, our objective is to display and analyze data in the creation of line graphs. So our two essential vocabulary words here are line graph, which is a graph that uses line segments to show how data changes over a period of time, and double line graph, which is a line graph that shows change over time for two sets of data. Again, a line graph is a graph that uses line segments to show how data changes over a period of time, while a double line graph is a line graph that shows change over time for two sets of data. So let's begin with the first example here. We're asked to make a line graph of the data in the table, and we're to use the graph to determine during which 2-hour period did the temperature change the most. And as you can see, the times and the corresponding temperatures are presented in the table. So let's go ahead and talk about the steps of making a line graph here. First thing we're going to do is determine the scale in the interval for each axis. As we've talked about with graphs in previous sections, there has to be a consistent amount that each axis, the x or the horizontal axis, and the y, the vertical axis, changes by. They've decided that they're going to place units of time on the horizontal axis. These times will go on that left to right axis, which means, of course, that the temperatures here that they've given us are going to go on the up-down axis. Then we'll place a point for each pair of values, connecting the points using line segments, and then we'll label the axes and give the graph a title. Okay, so first thing you want to take a look at is the times and the labels they have on the y-axis there. That would definitely be important information. Notice going across the x-axis, they've got 11, 1, 3, and 5, and those are the times that were presented to us. Realize that those are even sized. It's a gap of 2 hours between each marker, and you do want to have even sized intervals as you go through these different problems. On the y-axis, all right, we have the different temperatures, and notice they've used this squiggle here. We've seen this squiggle before. That indicates that they're skipping some numbers. Remember, you can do that, but you can only do it once, and you can do it only at the beginning to get you from 0 to somewhere you want to start. Since the lowest temperature they gave us was an 80, they could technically have started at 80 if they wanted to, but they wanted to start at 75, and then they went up by 5 to get us up to or over, whichever you need to do, your biggest number, 92. And clearly they've done that by going to 95. They've gone over. So at 11 a.m. the temperature was 80 degrees, so the 11 a.m. mark corresponds to 80, which is a number that's actually on the y-axis. That's why your dot is there. The 1 p.m. temperature is 88. Well, 88 is not on this axis over here. It would be between 85 and 90. Now realize exactly halfway between 85 and 90 would be 87.5. So you want to be a little bit more than halfway to show 88. Not much, but just a little bit. At 3 p.m. the temperature was 92 degrees. So realize again, halfway between 90 and 95 would be 92.5. So you want to be a little bit less than halfway between 90 and 95. And as the day reaches an end, the temperature comes back down a little bit. At 5 p.m. the temperature was 89 degrees, which is again not represented on the y-axis, but we have 90. If we drop down just a smidge from 90, that will be 89 degrees. As far as making a line graph goes, you are to connect the dots with line segments. It is not to be a curve type process. As you go from dot to dot, you should really be picking up your pencil each time to draw a new line segment. It's not a curve or a smooth curve, as some mathematicians will call it. It's individual line segments that go from dot to dot. Also notice there's nothing that starts the graph out here or even on this left marker because there is no data here. We have information for 11, 1, 3, and 5, and that's where the dots are. Notice they've also given the graph a title, which is one of the essential steps of creating a well-prepared graph. they've labeled this axis time and this axis temperature, which is also one of the proper steps in creating a well-prepared graph. And then they answer the follow-up question by asking, where did the temperature change the most? Well, that's going to be the steepest part of the graph. Whichever line segment is steeper, or the steepest rather. It does not matter if it's heading up or heading down, it's simply looking for the steepest. And the steepest change here is very clearly between 11 and 1. So the temperature changed the most between 11 a.m. and 1 p.m. Number 2, use the graph to estimate the population of Florida in 1950. Now realize why this is an estimate here. On the graph, looking at the year axis here, 1950 is not represented. We know where 1950 would logically fall, but technically we have no true data to represent 1950. It would at best be, as they're saying, an estimate of what the population would be in 1950 as opposed to the potential actual number. As they're saying here, to estimate the population in 1950, we're going to find the point on the line between 1940 and 1960, which will correspond to 1950. And that is right about there. Well, it is a little bit past halfway between 0 and 5, and we know the halfway mark would represent 2.5, as in 2.5 million. So that number would probably be a little bit too low. The book has estimated that this is even a little bit more than halfway, so they're estimating that that number corresponds to about 3.5 million people. And again, if you're looking to see how that matches up, draw a line from that point that represents 1950 to the left, and the number that that would correspond to should be right around that 3.5 marker. Again, there is no number there, but if we could separate that into increments, perhaps using a ruler, you would see that that is somewhere between the third and the fourth increment there, between 0 and 5, the fifth increment being the actual number 5 that is displayed. Example 3. The table shows stock prices for 2 stocks in 1 week, and we're to make a double line graph of the data. So as you can see, you have a table there that represents stock A and stock B, Monday through Friday, and the different prices that correspond to those. So we're going to plot a point for stock A for each day of the week. And then, using a different color, we're going to plot a point for stock B for each day of the week. And then we're going to connect the points. So let's take a look at the next slide here, where we actually look at how the graph is created. Now perhaps this is slightly more difficult to see because the graph lacks color. One of the things you would typically do in a double line graph is you would have colors that represent the 2 different lines you're creating in that double scenario, or if they went further out, a triple or quadruple line graph where you're looking at 3 or 4 distinct pieces of data. What they've done here, as you can see, is they've represented the one stock with a darker line and the other stock with a much lighter line. Okay, so let's go ahead and take a look at the actual creation of the graphs here. Stock A, which is the darker line that is on the screen, begins on Monday at $10 price per share, which is why you have a mark there. On Tuesday, the price goes down to $9. So as you can see, it drops down from 10 to 9. On Wednesday, the price is $11. So the price goes up, and it's got to go up past the Monday price, because remember, the Monday price represents just $10. The Thursday price is at back to $10, so back on that 10 marker that we established when we drew the axis. And then the Friday price shoots all the way up to $18, which is why you see the graph taking off. Again, between 15 and 20. Realize that the number that's halfway between 15 and 20 would be 17.5. It's got to be even a little bit higher than that. And of course, those points are connected, and that's how you generate stock A's line. Again, line segments connecting the different days, or the different points that represent the days. Stock B begins at 6. As you can see, it's much lower. This is the one that starts just above the 5 marker. On Tuesday, the price really moves up rather precipitously to 12. So this is this point up here. Realize that halfway between 10 and 15 would be 12.5. So not quite halfway, but certainly very close. The Wednesday price is $8. So it drops down beneath the 10 again. Again, thinking of that halfway marker, halfway between 5 and 10 would be 7.5, so a little bit past halfway between 5 and 10. And then the Thursday and Friday price are identical at $14, so coming just below the 15 marker to represent Thursday and Friday. Now, if you don't have different colors to represent the different lines, you can do as I did there. Notice that when I made markers for stock A, I used X's, and for stock B, I used dots. That is an option that is available to you. You could also make the lines different just based on how you actually make them with whatever tool you have, pencil or pen. You could make one, for instance, a solid line and the other one a dashed line. And then you would want to indicate here in the key what you did to represent each one. Notice that our graph has all the essential pieces of a well-prepared graph. It has a title, stock prices, because that's what the graph was about, and it has labels on the X and the Y axes that represent what those things are. It also has the key that we talked about, and neatness is inherent. Okay, let's take a look at the closing examples here. They'll begin with the first question, which is asking us to make a line graph of the data in the table, and then we're to use the graph to determine between which 2 months was the increase in the number of homes sold the greatest. So, beginning here, let's talk about the creation steps. Notice they have a title on the graph. It very clearly says over here that this is about homes sold in different months. So they just decided to call it homes sold. They decided to put the months down here on the x-axis. One of the things you should know is the time we usually use a line graph is when it's about time. And whatever that time increment might be, whether it's the hours or days of the week or different years, usually would fall on the x-axis, the horizontal axis. So as you can see, they've labeled them January, February, March, April, and of course those are even increments because they're 1 month to 1 month to 1 month and so on. Up the y-axis, since the numbers here that we have in the table are rather small, they did not use the line break or the squiggle to skip any numbers. They've gone all the way up to 25, which gets them over their biggest number. Remember, you can go up to or go over your biggest number. And they've gone again in even-sized increments. Notice that the jumps going up the y-axis are jumps of size 5. And again, both the x and the y-axis have a label, month, and the number of homes sold, which is what those represent. So the January number being 8, halfway between 5 and 10 would be 7.5, so just past that halfway marker for 8. The February number is 6, so up from February, just past 5 would be 6. The March number is 15, so up from March, I'm going to correspond with 15, which as you can see is one of the markers we have on the y-axis. And then the April number is 23. Realize between 20 and 25, exactly halfway would be 22.5, so just past the halfway point. Once you've made your dots, connect them with line segments, and you've created your line graph. Realize that no key is necessary here because you're only looking at the homes sold. If we were comparing, for instance, the number of homes sold in Nashville, which was one set of numbers, and the homes sold in Knoxville, which would be another set of numbers, you would have one line created one way, another line that would show up another way, and then you would have to include a key to say which one was Knoxville and which one was Nashville. But since we're only looking at one piece of data, that's unnecessary. Okay, here they're using a graph they used earlier, and they're asking us to use the graph to estimate the population of Florida in 1970. Well, remember what we did. 1960 is here, and 1980 is here. Halfway in between should be 1970. So if I go up from the halfway marker directly up and then read to the left, that number, whatever it would represent, would be the population of Florida in 1970. Well, as I read to the left, it's about perfectly halfway between 5 and 10. You can put your finger on the mark that's between 60 and 80 in terms of the years and read left, and you see it is about halfway between that 5 and 10 marker. So the population there is about 7.5, 7.5 representing 7.5 million. Okay, let's take a look at number 3. The table showing the stock prices for 2 stocks in 1 week, very similar to what we did earlier, and we're to make a double line graph of the data. So let's take a look at some of the key things they did there. First off, you see they do have a title on the graph, which is essential. That's one of the necessary pieces of creating a well-prepared graph. They have labels on the x-axis and the y-axis. They decided to put the days on the x-axis, and as I said a few moments ago, that time, whatever that time that's being represented, would usually go there. Monday, Tuesday, Wednesday, Thursday, Friday is what they have. They do have even increments happening there. 1 day to 1 day to 1 day. Going up the y-axis, if you take a look at all the numbers in the table, the biggest number here happens to be 14. So our graph on that y-axis set is going to have to get up to or go over 14 in order to be a proper graph. And as you can see, they've gone to 15, which would do that. Now, they decided to go by 3s on the y-axis, which is fine. But notice, since all the numbers are even numbers, it would have perhaps been a little bit nicer to go by 2s, because the 2s, every marker will be right on a corresponding y-axis point then. Notice it's a little bit different here than the question they did earlier, in that they did as I suggested. The stock A numbers are represented on a line connected with dots. Stock B's numbers are represented on a line that's connected with diamonds. This is the key. It's necessary because we're looking at 2 different pieces of data, in stock A and stock B being your 2 different pieces of data. And they have all the essential pieces of the well-prepared graph we've just discussed there. The title, the labels, the legend or key, whatever you want to call it, and the neatness is inherent. So, stock A's number is at 8. So up from Monday we find 8, we put a dot. Stock B's number is at 10. We go up from Tuesday till we reach 10 on the y-axis and put a dot. Wednesday number for stock A is at 6, which is on one of the markers that's already there, so we just go right up to the 6 and put our dot. The Thursday number is at 4, so we're going to go up from Thursday till we reach the area that corresponds with 4 to the left and put our dot. And the Friday number is at 8, so we'll go up from Friday until we reach the spot that corresponds with 8 to the left and put a dot. We repeat the process for stock B, connect our points, and you've made your graph.